Hello, and thank you for tuning in. In this video, you will learn about computer hardware and Intel x86 computer architecture. If you're watching this video, you're most likely an Engineering 30 student, and in one of the first lectures in the semester, Dr. Bob briefly talked about computer hardware, the CPU, or central processing unit, and DRAM, or dynamic random access memory. This video is an extension or an expansion of that topic. Next time you're in the Engineering 30 computer lab, take a look under your table at the large boxy desktop computers that are there. They're all made by Dell, Alienware, Hewlett-Packard. If you open up one of those boxes and remove all the parts, you'll have four primary components which you can see on the screen. And they are: one, a bunch of fans; two, a hard drive or maybe a solid-state disk; three, a power supply; and four, a motherboard. You are looking at a relatively small 6.7-inch square mini ITX motherboard with a pair of 2 GB DRAM modules and an Intel i5 CPU. Take a close look at all the wires, connectors, headers, and interfaces on the motherboard. There are interfaces for USB or Universal Serial Bus, video, audio, Ethernet, PS2, SPDIF, JTAG, and many more. Take a close look at all the electrical wires and note the color coding. Each color has a specific meaning. In class of late, Dr. Bob has been talking about some electrical engineering topics such as voltage, current, and resistance. So these wires are relevant and of interest. Black wires, as you may expect, are ground. Orange wires carry 3.3 volts. Red wires carry 5 volts, and yellow carry 12. Blue wires are negative 12 volts, and that gray wire going into pin 19 is positive 5 volts and carries a power good signal to the CPU every time the computer is first powered on. Take another look at that enormous orange CPU fan sitting atop a large heatsink. This all provides cooling to the CPU. In the next couple of pictures, you'll see me slowly remove the CPU fan, the heatsink, and show you the CPU and some other components that are on the motherboard. Take note of the two unoccupied connectors to the left. Those slots are where the DRAM module sits, and you'll see them in there in the next picture. This is the heatsink with that big orange fan removed. This is the underside of the heatsink on the left, and the exposed motherboard with the CPU in the middle on the right. Note the CPU is covered with a soft, gooey gray CPU paste that ensures good thermal contact between the CPU and the heatsink. If you were to touch that CPU with your finger while the computer was running, you would almost immediately receive a third-degree burn. CPUs run very hot, and cooling is a big issue in computer design. This picture shows the CPU removed from its socket. Notice the little square hole in the middle of the socket. Also take note of the two memory modules that are now inserted into the memory sockets. This picture shows the same two memory modules removed from their sockets and lying on their side for you to get a good look at it. There are 240 contacts on each memory module, 120 on each side. These memory modules cycle at a clock speed of about 1.3 gigahertz or 1.333 times 10 to the 9th clock cycles per second and draw about 1.6 volts. This is the underside of the CPU and probably the most interesting picture in this sequence from my point of view. This is an Intel Sandy Bridge 2.6 gigahertz i5-2100 CPU in an LGA-1155 form factor. It was made in 2011. It draws 12 volts and 65 watts. There are 1,155 pins on the bottom of the CPU, and hence the form factor name of LGA-1155. Take a close look at the small rectangle in the middle of the CPU. That is the CPU. It measures about 1/4 inch on one side. The rest of this chip is nothing but packaging for wires that run from the CPU to those pins. There are 1,155 of those pins. Note also the interesting mathematical relationship between the two 1.333 gigahertz clock speed memory modules and the 2.6 gigahertz clock cycle on the CPU. This picture is the underside of the motherboard. You can see 4 spring-loaded thumb screws that anchor the heatsink. On the right are the underside of the contacts for the 2 DRAM modules, and on the left are contacts for the PCI Express slot, which is not something I've talked about in this video. This final picture shows an identical system mounted vertically on a piece of Lexan. You can see the motherboard, some of the interfaces and connectors such as video, USB, and Ethernet. In the middle is the CPU fan. Along the bottom are the memory modules. There's also an Arduino and a breadboard connected to the system through a USB port. On the right is an exposed hard drive inside a sealed plastic case. Note how shiny and reflective the disk platter is, and look closely at the center of the disk to note that the disk drive is off and the platter currently is not spinning. This is the read-write arm on the disk drive. Along the bottom of this picture, you can see the power supply partially camouflaged by an OCZ solid-state disk. This video shows the same system. This time it's up and running. It booted a copy of Linux. Look closer at the hard drive. It's spinning at about 7,200 RPM or 120 times a second. You can see the read-write head move when the disk reads or writes information off the drive. Now, while this picture shows a rather confusing array of wires, devices, connectors, and interfaces, all of these pieces can be thought of as one of 5 types of components. They're either input units, such as a keyboard or a mouse, output units, such as a display, or input and output units, such as a disk drive or a network interface. There's a process unit, the CPU, and there's a memory store where information and software live when executing. So, to better understand this picture in computer architecture, think of an input unit, an output unit, a processor, real storage, and auxiliary storage. And everything in the picture falls into one of those 5 categories. The operating system, the C++ compiler, your Arduino development environment, and your Arduino programs all exist as files stored on a disk or on a solid-state drive. Those files are read into memory by the CPU and executed from there. And that concludes this overview of computer hardware and Intel x86 computer architecture. I hope all this information is useful and educational. If you want to see all these pieces, I can bring them into school, and if at any time you got questions or want more information, please let me know. Thank you for watching.